Okay, cool. So for Pong, I did give you a zipped file that had the code in it actually, but we're going to code the code ourselves so that we can learn how to code this code. Okay, and we're going to start with a blank flaw file and code the whole thing. There's one function in there you might want to copy and paste. That's pretty much why I give the code. The artificial intelligence function is a little bit long, so we do like to copy and paste that one. And then I did make a PDF of directions for this assignment. And then this last one, I need to change it, but it's just a text file with the code inside of it. All right. Oh, yes, and we can get the lights if you want to, actually. Candace, thanks. All right. And there is videos that go along with this one. So if you do get behind or you miss a day, then we have videos that go along with this one, too. And actually, the videos that go along with this one, there's like 10, because it is a little bit longer to code. Okay? All right. And we go over a couple other things, like how to adjust our hit area and how to make a score. Okay, so we're adding to our programming knowledge here. But we're going to go ahead and start with a blank flaw file. So if you get Flash open, you can go to File, New. We're going to start with a blank ActionScript 3.0 file like we've been doing. Okay. And you can adjust the height and width if you want. So I'm going to adjust it to, let's say, 800 by 500, I think was a good height and width. And then after you've created the file, make sure you save it. So do a Control S and save your file. And you can save it as pong.flaw. And what we'll program today is we'll program our ball, and we'll make him go in the in the middle of the screen, and then we'll program him to move, and then we'll program our paddle, our player's paddle, and make him listen to our taps, okay, our clicks, button clicks, and then we'll program the other paddle. And then you guys will be in charge of switching out your characters. And I think hopefully we'll get through all of that today. Maybe we'll just get through the ball and then the player's paddle. Okay? All right. Do most people have this open now? If you want to, you can change your stage's background color. A lot of times I don't like to look at the white background, so... And remember that you can put your own background on there. So when we have our breaks, when I'm coming around helping people, you can choose a background. And you can start to think of your theme for your Pong, you know, what theme you want. Okay? So you can choose whatever theme you want. All right. So, and we can even follow my methodology and the directions here. So the first thing that we do is we're going to make our player. And... I mean, not the player, the ball. Right? Oh, no, I do make the player. Okay, so we'll make our player first. And our player is just a paddle that looks like this. And remember that we could change him out later and make him look like a different character. Okay, it's very easy to change our movie clips out. And so what we'll do is we'll go over to our flaw file. And... when we're first creating this thing, remember that we can just make our movie clips kind of generic, and then we switch them out for better players. So for now, you can just use your rectangle tool. Rectangles are good paddles at first. Here's my fill color of white. You can change your fill color real fast if you want. Remember that later on I'll change this player out, so I don't want to spend too much time making this rectangle look nice. And then I'll just draw a rectangle on the screen. I'm not going to make him an exact height and width because remember that we are going to change him out. We just kind of make a rectangle for our paddle to test with. So I just drew a small rectangle there. And then we're going to make him into a movie clip so that we can add him into our code through our code, and also so that he can respond to our event listeners. Okay. And so if we press the F8 key, then we can name that movie clip player. And remember to name your movie clips with a capital letter, because they are class names. And because we're going to write external ActionScript files, we'll export for ActionScript. Remember, we always kind of check mark that box. It makes that external file for us. And then we press OK and OK. And you'll see him over here in the library, so now I can delete him from my stage. And now I can add him through my code. Alright, so now we're going to add him into our code. And at first we do make him listen to the keyboard functions inside of my directions. But if we want this to translate to our e-pads and to work well on our e-pads, we'll change this to a click function. Okay, because remember that, you know, clicks turn to taps, and then it works better on the e-pad if we can tap. Okay. Alright. So we're going to make a separate AS file for our game. And so kind of the easiest way to do this, and to make sure it's in the right location and it just works better, if you click off of everything, go to your properties panel for your flaw. And remember that little text box over there? That's where we can write our class name. And remember to name your class name with a capital letter. And I just named it Pong, P-O-N-G. You can name it whatever you want. Okay. And remember to open it, you just click on that little pencil icon. He actually creates the file for us at first. So we say, yes, make that file for us. And then you click on the pencil icon again, and it'll ask you where you want to open it. And it should open in your, or you can open it in Flash Professional. And then importantly, save it. Okay. And it'll want to save in the same file folder where the flaw is, which is where we want it. So we just press OK, and voila, we have our beginning of our game. Now, one thing that we've been kind of bad at that we should start getting better at is we should start putting our name up here at the beginning of our files. It is a good habit and a good practice to get into. So we can add our name at the top as a comment. So in your pong.as file, put your name. And then a lot of times, programmers will put the date up there at the top. And today is the 29th. And then you could put other comments about the file up here at the top, if you wanted. And remember that this package declaration starts our program. And then you guys remember what these import statements do. They let us use the reusable code. Okay, so remember that when we import these libraries or these classes, we get to reuse them. Remember, this is where we put all of our functions inside of our class definition. When it says extends movie clip, that means we're inheriting from the movie clip class, which is how we mostly do things. And then remember that you can name your curly brackets, because we are going to have a lot of functions in here again. Okay. So if we start naming our closing curly brackets, we won't put our functions in the wrong place. So I'm going to name that one the end of the class. This one's the end of our package. And then this one is the end of our constructor. Okay. So that way we'll get our functions in the correct location, and it'll help us in debugging our code. If we name those ending curly brackets, I found that when we do this, we have a lot less errors in class. All right. And remember what our constructor code does. Remember that this constructor code is the code that's run when we start our game. It makes an instance of our game, and so the constructor code is run. It's kind of like our main in a way. So remember, above the constructor code is where we're going to put our variables. And do you remember the name of our variables? What they usually call them? Do you guys remember the name? I usually call them a name that starts with an I. Do you remember the name? Everybody together? Hector? Yeah, or instance variables. A lot of times I call them the instance variables. In some books and documentation, they can also call them member variables. Okay. But remember that these variables are what describe our game and allow us to remember things in our game. Okay. Such as making our player object, which we're going to make right now. All right. So we'll make a player, we'll call him player 1. Remember that you want to start your variables with a lowercase letter. And you can name him whatever you want. Remember that you just kind of name him something that makes sense to make our code readable. Okay, I'm going to name mine player 1. And then we put our colon, and then we put the type of variable he is, which he will be a, what did I name it over here? Oh, he'll be a player object. Okay, because I named this guy a player object, so he's going to be a rectangle. Okay. So this declares him. Remember, this is our declaration. Okay, we're declaring our instance variables. Okay. So we declare them outside of the constructor, and then remember, in the constructor is where we instantiate them. Okay, so remember that this is our declaration. And remember, you know, all of our games kind of follow this pattern, so we should start being able to pick it up now, right? Is it starting to make sense? We always kind of follow this pattern. We make our instance variable, then we instantiate our instance variable in the constructor. And we always kind of do it the same way. So we use that new operator. So we say, okay, player 1, you equal a new player object. And this is his constructor, actually. So we're calling the new player constructor. And then we'll want to change his x and y values. But I'm going to let you guys kind of figure out where to put the x and y values. I think we've gotten to that point you guys could figure out where to put him. Okay. And then after you figure out his x and y values, in fact, we're going to, right here, and then after you figure out his x and y values, then we'll add him to the stage. So very importantly, we always have to add him to the stage with our add child method. Okay, so where is he going to appear now? We should have some idea of where he's going to appear. If I don't change his x and y values, remember the default is the upper left-hand corner, right? So his x and y will go to the upper left-hand corner. And his x and y, if you can look here, his little crosshair thing is his top left corner, so he's going to appear right there. He should appear right there because that's the default. We would like him to appear right here. Okay, so that way he appears in the middle, so it's fair, right? So we can start in the middle. But let's go ahead and run our code first, and then you guys can figure out your x and y value. Oh, and I left that one on the stage, so that's the second one you're seeing here. I have to delete him from the stage. But you should see your player object, of course, appear on your stage. And he appears in the default location. So you guys can figure out how to make him appear down here. Remember that this is the positive y. And this is the positive x to the right here. Notice that his x value doesn't have to change, right? If we want him to be smack dab against the left, you can leave his x value as the default of 0. But his y value does need to change. I was hoping you guys could think how to change that y value. So what would his y value be? What do you think? Yes, very good. Well, almost. We can do stage.height divided by 2. But I'm glad you said stage.height and not just a number like 200. Because remember that if we hard code a number in there, when we go to change our stage, maybe for a different like E-pad width or something, if we hard code numbers in there, it makes it harder to change. But if we use things like stage.stageHeight, then when the height changes, so does that variable, and so it's adjustable automatically, right? So he said stage.stageHeight divided by 2, which is really close to where we want him. But notice he's down a little bit, and do you know why he's down a little bit? Because remember that the stage.stageHeight divided by 2 this is the exact middle. But what did it put there? It put his crosshairs upper left-hand corner right there. So we have two choices. We can change that player's crosshair to be in the middle, or we can just leave it up there in the upper left-hand corner. And then what would we have to subtract?
Half the height of the player.
Yeah, very good. Yeah, you could subtract half of the height of the player, and then he would be in the right location. Okay, very good. So there, you could do two things, but I think the easier way to do it is just subtract and leave that the default upper left-hand corner. And you could just say player 1 dot height divided by 2. And if I subtract half of the height of the player, then he should be in the exact middle on that side. You can see that he is. That's great. And remember that this will adjust. So when you change out your player and he becomes a different height, since we use this variable, it'll adjust to your new player and you won't have to change your code. That's why we like to use variables instead of just hard coding like a number in there. Can you guys see how that'll adjust as we as we change this? Okay, so now we're going to add an event listener. I think we're going to change this a little bit. Now notice that this is listening to your keyboard codes. But I think we're going to program it a little bit different this time around. And then if you wanted to program your keyboard code, you guys have the directions where you can change this to listen for your keyboard code. And just listen for the up arrow and the down arrow. But I think we're going to go ahead and just program it to listen for our mouse click. Okay. So we want to add an event listener. And what do we want to add the event listener to? To the player or to the stage? Can you think?
Player.
Now if we add it to the player, when we run this thing, you'll have to be clicking on the player to move it. And it might be kind of hard. Because remember that when you add an event listener to a player, you have to click on the player. But if we add it to the stage, then you can click up here to move them up. You can click up here to move them down. I don't know. Okay. So we'll try the click one today. And then we can also listen to our accelerometer. So we'll do our accelerometer section. Okay. An accelerometer is you can tilt it like this and then make the player move. But remember, the accelerometers only work on the E-test. Alright, so let's add it to our stage. Let's add an event listener to our stage. And we're getting good at adding event listeners, I think. So remember that the first parameter, or actually the first argument in our add event listener method, we want to put what it's listening for. We're going to listen for that mouse event. So if I start typing mouse event in Flash Professional, you can see that it brings up that mouse event click. And when I add it through the code that way, notice that it did add my import statement. So if it didn't add your import statement, make sure you add this, because this is how we get access to that reusable code. But if you use that code complete in Flash Professional, it does write that import statement for you, which is kind of nice. And you guys remember what the second argument to our event listeners are? We should start remembering this guy. Remember, our first argument was always what we're listening for, and then our second argument is the method that we call when it hears that event. Remember? We should start to be able to remember that. So we can call it the move player one method. That's what we're going to have it do, so it's good to name your methods or your function something that it does. So we have to write this function now. This will be our move player one function. So double click Control C. And remember to come outside of your constructor, but before the end of your class. This is where we want to write our new function. And we always write our functions the same way. We always put public function, the name of the function, and then its parameters. And remember that when we have a listener function, we do have to put as its parameter the event that it was listening for. And then we put its return type, and this function doesn't need to return anything. It's just going to do something for us. So whenever it hears the click, it'll call this function. And I put my beginning curly bracket and my ending curly bracket up here. And then I'm going to name that ending curly bracket, kind of follow my methodology of naming my ending curly bracket so our code stays nice and neat. All right, so how are we going to know where we're clicking on the stage? So that's what we need to program here. So if I'm clicking up here, I need to know that I'm above the player. And remember that his reference point is here. And if I'm clicking down here, I need to know that I'm below the player. So I need to listen for that event, and now I need to use that event and get the X and Y value of where I clicked on the stage. Or actually, just the Y value, really. I don't care about the X value. I just care about my vertical value. If I'm above the player's Y value, then I'll go up. And if I'm below the player's Y value, then I'll make him go down. Okay. So here's where we're actually going to use our event finally. Notice that we always pass them in, but we've never really used our events that much. One time we used them to figure out what keyboard presses we were pressing. So at first, just to see how this mouse event object that we called E works, to go ahead and just trace them. Remember that when I trace something, it just outputs to my console, which is a good debugging tool, just so that we can see how this event object's Y value works. Oh wait, I think I wrote something correctly.
Stage Y.
Local X. Wait. Oh yeah, so it's local Y. Wait. Actually, oh yeah, that's right. So I deviated from the code a bit, so I had to remember. And notice how I remembered that. It's good to see how we can remember things like that. I just put the dot operator there, and then it brings down all of his properties. So remember that if you forget something, you know, actually here's stage one. You just kind of look and you see all his properties and the methods that you have available to you. So a lot of times you can figure out what you want by just doing that dot operator and scrolling through there. Okay, that's what makes that little code complete box really helpful. Okay. Actually, let's print out both of those and see the difference. So he had some variables associated with him, so we might as well just kind of check him out. And I'm interested in his Y value, his vertical value, so I'll just go ahead and trace those two variables that are, they're in his instance variables. And remember that you can test it then. And in your console, actually those are the same values, right? I think if we had nested him, they would have been different. But he's not nested. He's only nested in this stage. So did everybody kind of get that one to work? You can see your tracing of your variable there. So now we can use that number. Okay. Now remember that the reference point for our player object is in the top left-hand corner. And so if we click up here, what if we click like right here? So remember that his X and Y value is going to be here. And that our mouse's X and Y value is going to be where we're clicking with the mouse. Okay. So if we click right here, we check it against his X and Y value, or his Y value. His Y value is going to be less than this Y value, because remember that this is the positive Y direction. So I'm thinking that I think it would be in our best interest, actually, before we start programming any further, to make his reference point in the middle of him. Do you see how that would work a little bit better? I think it'll be better to debug him a little bit. And it's really easy to change. And it's good to see how to change that. Okay. So let's go ahead and edit. In our flaw file, let's put his reference point in the middle of him. It's actually pretty cool. So go back to your flaw file. Take an instance of your player, or just double click over here on the left. I mean on the right, sorry. So either double click him here or drag him to the stage and double click him. But we want to get into where we're editing our player object. Remember to look up here on the top left-hand corner. You'll see that you're editing the actual player object with his timeline and everything. And what I do is I can just drag that rectangle so that his crosshair is in the middle of my player object. And that puts his reference point on the back and in the middle of my object. So that way when we're clicking our mouse and we click right here, it'll be above his Y value. You see how if we make that reference point in the middle, it'll work better when we're clicking our mouse. And then when we click down here on the stage, it'll be below his Y value, and so it'll make him go down. That way he'll play a little bit nicer. Okay. So after you're done editing him, to get out of edit mode, you can go back to scene 1. You can see that his crosshair, if you had a copy of him on the stage, you can see that his crosshair reference point is in the middle now. And if you made a copy on the stage, you can delete that instance from the stage. Okay, so let's implement our logic here. I think we can think how to implement this logic. We're going to have a branching statement, and it's going to check where we're clicking the mouse in reference to where our player is located. So we can have a branching statement. We can just have an if statement. And we could say, okay, if where, the Y value of where we clicked on the stage is less than our player 1's Y value, so it's going to go and retrieve where we clicked on the stage, and it's going to look at where the player 1's Y value is. We want the player 1's Y value to increase or decrease. Where we clicked is less than the player 1's Y value. So let me show you on our stage here. So remember that that the 0 Y value is here, so 0, and it goes down to 500. So my stage is 500 pixels wide. So if where I'm clicking is less than his Y value, I'm clicking up here. You see how his Y value is growing this way? So if it's less than, I'm clicking up here, right? So if we want him to go up, what should we do to his Y value? Huh? Yeah, decrease. So it's 50-50. Either increase or decrease. But yes, decrease, because we want him to go towards 0. We want him to go up. Okay? So we can decrease him by a certain amount, and you can play around with these numbers. But you can do a minus equal like 5 pixels and see how that works. So we'll just write a couple of lines of code and then we'll test him again. And you can see that if I click up here, and he does actually go up. And if I click down here, he doesn't go down. And why doesn't he go down? We haven't told him to go down yet. Okay, so we need to program that. Do most people get that one to work? Now remember that 5 pixels is not very high. Now what if we wanted this to run constantly and not just be an if statement? We'll run it like this for now, and then we can change it. When we add our frame.internet. Now notice if I keep clicking above his Y value, he'll just keep going outside of the stage. So we need to make sure that he doesn't go out the bounds of our stage. We'll have that check in there also. Okay? Unless you like him to go outside the bounds. But let's make him go down first. So you guys should be able to figure out how to make him go down with this kind of methodology. What do we need to change here? Just a couple of things. So you can take that code and you can copy it, because the same kind of logic is going to apply apply for when we want to move down the stage. In fact, we can even label our if statements so we remember what they do. This one's going to help us move up, and then this one's going to help us move up. Now what do we need to change right here? Of course we need to change our comparison operator. So now we need to check if where we're clicking is greater than or on the bottom half of our player. So we need to change our comparison operator, which makes sense. And then of course we need to change this minus equal to a plus equal so that we actually increase him. And you could add a little bit more pixels in there. Now, our game right now is playing a little awkwardly. I'd have to say this is kind of awkward. Keep on clicking the mouse. I should be able to click once and then he should blow up, don't you think? Yeah, you should be able to click once and then he should just keep going up till I click on the bottom, right? So let's fix it. We'll fix him right now. We might as well fix him. And we can think how we would fix him. So what we want to do is we want him to keep moving up until either he hits the top or we click down here. And we want him to keep moving down so either he hits the bottom or we click on the top again. Okay, so if we want something, if we want to keep on adding to his Y value, can you think what kind of event listener we need? We need the event listener that kept looping in our program 24 times a second. Do you remember that one? Yeah, the frame enter event. So now we'll introduce our clock because we're going to need our clock anyway. For any type of game, we need like some kind of timer or clock so that we can, make our game happen. You can think in reality things wouldn't ever happen if we didn't have time, right? So same thing with a game. We need to put a time in, timer. Okay. So let's listen for our mouse event, and then we'll implement it a little bit different. Okay. All right. So let's put our mouse event for our on-frame enter. So this is where we're going to start our clock. We can even put start the clock. We can think of him as a clock or a timer. So we'll add an event listener again. And I'm going to add him to the stage, which makes sense. Every time we program this guy, we program him a little bit better, right? All right, so he's part of our event library. Remember that this is a constant variable we're listening for here. And then a lot of times we call the method that we call on-frame enter. Remember that you can name these methods whatever you want, but you should follow the methodology of a lowercase letter here. And then we might need to, it didn't automatically add my event library up here on the top. So remember, if we're going to use this event, we need to put our event library up here. Our import statement. Go ahead and put my import statement now. Otherwise, we'll get that compiler error saying he doesn't know what our event class is. So he's set up. We got our listener event set up. Our listener function. And so now we're going to write our on-frame enter method. Let's go ahead and write that. Remember that we'll get a compiler error until we write this function. Okay. So we'll write them down here. Put them in our list of functions. Remember to put them outside of the other function, but before the end of your class. And we set them up the same way. We follow our pattern. So in order to make this work, what we're going to do is we're going to make a Boolean value. And we're going to use that Boolean value inside of here to know if we're moving down or moving up. Okay, and we're only going to be able to change this Boolean value when we're clicking. So we're going to modify our code a little bit. Okay. So we're going to create this Boolean value as an instance variable, and what we're going to do is he'll be true when we want to move down, and then he'll be false when we want to move up. Okay? So what we'll do is we'll make him in here, and we'll call him move down or something. And we'll just make him a Boolean value because he's going to be like a state variable or something that's going to be true or false. A lot of times in games we have these state variables. Remember, to be a Boolean value, you only can have two values, either true or false. Boolean means true or false. Fits right in. All programming languages have Boolean variables because we're built on computers that are binary, and binary is 1 or 0, true or false. Okay. All right. So declare him up here. We'll instantiate him down here. So I double-clicked and Control-C so I can make him down here. Remember that we'll instantiate him in our list of instantiations, so I'll just instantiate him right after the player object. I'll set him equal to a new Boolean. And then we can give him a default value. Now you can start them out default true or default false, it doesn't really matter. If I have a default true, that means he's going to start moving down right away. And so what we're going to do after you create him, make sure you write these 2 lines of code in your constructor to make him. Oh, yes. Mu, new, new, new. You don't know what mu is. Okay, we gotta make sure we get our color coding right. That helps us. Thank you. And then we'll come down here. Now instead of moving him up and down this way, what we're going to do is we can just, comment this out. And what we're going to say is, okay, move down equals true here, because that's when we're moving down. And move down will equal false here, because that's when we're moving up, right? No, I got them backwards, sorry. That's when we are moving up here. I even put code up here to move up, so this is where he'll be false. Because move down is false when we're moving up, and move down is true when we're moving down. Does that make sense what we're doing? So we made this Boolean variable, and now we're just going to set this Boolean value whenever they click. And then on our on-frame enter, if move down is true, he's going to keep on moving the player down. If move down is false, then he's going to keep on moving the player up. kind of make sense? So this is where we'll put our branching statements to check if move down is true or false. So if move down is true, we can just put if move down, because if he's true, it'll make that Boolean statement true. And we can even write some comments to ourselves. Move the player down, right? So move down is true, not here, true. Then move the player one down. And remember that we like to put comments in our code because it helps us to read our code and remember how to change it. But remember that comments are ignored by our compiler. So if move down is true, then we move our player down. So I can copy and paste this code that actually worked to move him down. Now I'm just going to copy it right here. Remember to indent him. And then I can say if move down is false, or I can just put an else statement because if he's not true, he will be false. So I can just put else right there. That works. Remember how our if statements work. If this is false, it comes to the else part and runs our else part. And if he's false, then I do want to move down. So I will go ahead and, if I know if he's false, I want to move up, right? So I'll put my other movement of minus equal 10 down here, and voila. So do you see how this is working? When the user clicks and makes this false, it'll run this part of my code continuously 24 times a second. Actually, minus equal 10 might be too much. You might have to change that minus equal 10 to a little bit smaller of a number if you wanted to move smaller. And remember that if we click a below my y, the click event will happen, it'll make move down true, and then when it comes here for 24 times a second, it'll run this part of my code. So we're just, using our click event to set this state variable. This is called setting the state variable in the click event. It sets that state either true or false. And because this code is continuously running, whatever that state variable is set to is how that player will move. So does that make sense how we did that? Hopefully everyone can kind of get that. This is a common way to kind of do something like this. Set a state variable with a click function, and then use that state variable in the running of our game. Call it the state variable. It's either in the move down state or not in the move down state. So if you test him, oops, I make sure I'm testing this guy. So if I click up, he starts moving up. If I click down, he starts moving down. Oh, he starts leaving. Now when does he stop moving up? Never, unless I click down. Unless I click below him, right? And when does he stop moving down? Never. He keeps on moving down forever until I click above him. So he can go all the way down, down, down. He's probably way, 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 way down now. And I click up, and eventually he'll come back up. So what do we need to do in here? Yeah, we need to tell it, just like how we did our Flappy Bunny, the same kind of way. We need to check. See, there he was. Eventually he does come back. There it is. But yeah, we need to do that check just like we did with our Flappy Bunny, that if you hit the edge, don't move down anymore. Right? So only run this code if you haven't reached the edge yet. So I think this is a good place where we can use a logical connector for a Boolean statement in here. This will be good. We need to figure out that part anyway. So we're going to have an if statement in here, and we're going to check if the player is moved outside of the screen. here we're going to check to see if the player 1 has left the stage, or is going to leave the stage, or has hit the edge of the stage. So we're going to check to see if the player 1 has hit the edge of the stage. And if he has, then we're not going to run this code. So what we're going to say is, okay, if your player 1 Y value is less than stage less than 0. Oh, no. Greater than 0, sorry. Because if he's less than 0, he's way up there, so we don't want to run the code. But if he's greater than 0, that means he's down here, and then we want to run this code and let him move. So if he's greater than 0, then we can go ahead and run this block of code. This block of code doesn't actually need curly brackets since this is the only kind of statements underneath it, but we can put some curly brackets here. So I'm going to put one here. And because I'm using curly brackets, I'm going to indent this code to make it properly aligned. So remember, if you want to indent a block of code, you select the block of code and hit Tab. Label my ending curly brackets there. All right, we can test this part. So remember, if the player 1's Y value is greater than 0, so that means he's down here. We should put greater than or equal to 0, right? Greater than 0. Actually, he should have stopped when he got up there.
He didn't set his Y value to stop him from moving.
Oh, yeah. We need to put an else statement right here. So if it's greater than 0, then yes, we want to move. And if it's less than 0, what do we want to do? We want to make him stop. So we'll put a little else part right here. And we'll just say, okay. Actually, he shouldn't have added 10 anymore. Because this code should have only ran when he was greater than 0. Now this on-frame enter is like a continuous while loop. So remember that on-frame enter is happening 24 times a second. In fact, we can even, if you wanted to, you could trace out your player 1's Y value. So this is a good way to debug, is you can use some trace statements. Okay, so whatever reason, maybe I didn't save it before. Now he seems to be behaving properly. But notice that, whenever we want to debug something, a lot of times I just do this old school kind of way of debugging where we just print out what our Y value is to make sure, yes, he was becoming negative. And when he did become negative, this became false. And so if it became false, we don't add 10 to his code or to his y value anymore. Remember that this is false. We don't get to run any of this code in between these blocks. Because remember, it's false. It skips it, right? It goes outside, you know. This is false. It goes to right here. It doesn't go in here and run this code. So he doesn't add or subtract 10 from his y value anymore. So he should stop. Now, notice that we've only checked if he goes up. We haven't checked the down. And if you wanted him to stop not halfway, how would you make him stop not halfway?
Add player 1.height divided by 2 to the 0.
Yeah. So notice that what it's doing, very good. Yes. Good. I'm glad that you saw that. So what it's checking right now, so we can visualize what it's doing. Here's his x and y value. So here's his y value. When his y value becomes 0, he stops. But how about if his y value became this number right here? What is that, like 50, whatever that is? Now I don't want to hard code this number, but I could say, okay, if you're down, your player 1.height divided by 2, if you're right here, I want you to stop. Okay. So instead of putting 0 right here, you could say, okay, when you're greater than player 1.height divided by 2. And that way, instead of stopping at where he's 0, he'll stop at player 1 height divided by 2. He'll stop right before the 0. Right before he gets up that high. So remember that he's only going to move, or only get into this if statement, if he's greater than player 1.height. Otherwise, he just stops. You can see him working. Oops, I left the other guy on the stage there. But you can see that he stops when he comes up to the top of our screen. Right, let me delete our other player that I had there. Now we need to make it so he'll stop on the bottom. Yes?
Won't he not go again once he hits the top?
Yeah, no.
Okay.
So now he's stuck because we can't change him right now, because if we click down here, it's not, this is always false. It's not going to be true again ever unless we put another check in there. Okay, so what we're going to do is, we're actually going to use an OR statement. I don't think we've used OR before, so we wanted to use an OR statement today. I thought we could use a logical connector. Okay, it's a great place for an OR statement. And an OR. So what we're going to do is, okay, so if you're greater than, or if you're not at the top of the screen, so this is checking, hey, if you're at the top of the screen. In fact, we can even put comments in. Oh yeah, we already put that, hit the edge of the stage. Or, and we're going to use OR right here. And the OR operator is above the backslash. It's in between backspace and enter. You push shift, and it looks like there's a line and then a hole and then another line. It's above the backslash, but when you put shift and you hit that key, it does make a straight line up and down like that. And this is called your OR operator. And let's write the rest of this, and then we'll explain how our OR operator works. I think you guys will get it when you see the example. So we want to check it in the other direction. So we'll say, okay, if player 1.y is less than stage.stageHeight, because remember that if he goes beyond stage.stageHeight, he's down here at the bottom of our stage, and we don't want him to go anymore. So we'll check that he's staying less than stage height, then we can move up and down. And the OR operator works this way. You connect two Boolean statements together. So notice that this is its own Boolean statement. And on the right side of the OR is its own Boolean statement. And OR makes sense. This whole Boolean statement is true if the left side is true or the right side is true. They don't both have to be true, but one of them has to be true. The only way that this can be false is if they're both false. Okay? So actually this will work pretty well, I think. So we can save it and we can run him. Notice that when he hits the bottom of the screen, did I put that the wrong way?
You need an and.
Oh. Oh yeah, because, you know, I was thinking OR. Now this is good that this failed like this. Because this one was false, but was this one still true? Yes. And so we're going to try out the AND operator. Now you can think how the AND operator works. An AND operation is true only if both sides are true. So if this is true and this is true, then the whole thing is true. If this side's true and this side's false, then the whole thing is false. And if this side's false and this side's true, then the whole thing is false again. And if they're false and false, it'll be false. So the only way an AND operator can be true is if they're both true, which actually makes sense because we want him to stay in between both of those values. So the AND operator looks like an ampersand, two ampersands together. It's above the 7 key on your keyboard. So if you hit Shift 7, you put those two little ampersands together. They can't have space in between them. And so when he moves down, what happened? This part of our AND statement became false. So it was true and false. And so this part of the code then does not run because this whole statement becomes false. Oh, but we need to move him up a little bit. So now we're stuck a little bit.
Did you take out from the move player function, did you take out the line that increases or decreases the y value of player 1?
In the if statement?
Yeah.
Yeah.
If you leave that in the move player function, it will fix that.
Yeah, right here.
Yeah.
So what we could do is you could even just increase it by 1 pixel and then he'll work again. Okay. So notice what's happening here. It's good when stuff like this happens, we can start realizing what's happening in our code. And what's happening is we're clicking. So actually, you know, it becomes true, but this if statement's still false because we can't get in here to move them at all. Okay, so once this becomes false, we can never get in here again unless your player.y's change somehow. So we have to change them at least by 1 pixel, and then this can be true again. Okay, and then it will work again. So remember, that's kind of like a gate, and it's locked right now. It's locked when we're false. Okay. So we just have to move in by at least 1 pixel when we click on it. So what we'll do is we'll come up here and we'll fix it. No biggie. I think this makes sense to put it up here in our if statements when we're clicking in our click event. So I'm going to notice that when we only have 1 line of code happening after an if statement, we don't need curly brackets. But now that we're going to run more than 1 line of code after our if statements, we'll want to put curly brackets here. Encapsulate or make that a block of code, it's called. So I'm going to put my beginning curly bracket at my if statement. And my ending curly bracket here in my if statement. And then I just need to change that player's y by 1 pixel at least. I could do 10, but you could do it, you know, if it's 1. You could try out 1 here. As long as he's changed by 1 pixel, what that does is this will make this true again, and then you can get into here to move them again. You just get stuck because this will always be false because this isn't changing anymore, and the only way that this was changing was in here, and so we got stuck. Okay, that makes sense? So what I added was right here. We just said, okay. Actually, we should just do 1 pixel, right? So that way he doesn't jump, right? We don't want him to jump. And then down here we'll do the same thing. We'll put some curly brackets. We want to run more than 1 line of code now. And we'll just increase him by at least 1 pixel so that we can get into that if statement and it'll be true for us. And this is actually some pretty good logic we have going on here. Okay. It's simple and it works. We're just using a simple Boolean state variable and just changing those Y values of our player. So he gets stuck down there. Now he's stuck. But if I click, it'll run this click code. Remember, it's listening for a click. And then it'll move in by at least 1 pixel.
I think on the on-frame enter.
Oh, I need to move it by more than 1 pixel.
No, well, I moved mine and it works, but I think on the on-frame
At
enter
least
one.
10. Yeah.
Stage height minus player 1 divided by
Oh, yeah. Well, that'll make him so he doesn't
well,
go
he won't
halfway
like go
down.
halfway. I don't know if that
I was going to let you guys fix that part. Oh, yeah. So I got to move him by more than 1 pixel. 1 pixel is too few for him. So what I did, just so you saw, instead of 1, I just put at least 10. Just because it wasn't registering right. But it seems like he doesn't jump, actually, so I'm good. So notice he does stop halfway down. I'll let you guys fix that part. You can think how to fix that part, hopefully. I'll show you where you can fix that part. And then when you click up, remember what happens. It runs our click function. It sees where we click on the stage. Remember, it does the e.stagey. This will become true. Move down variable, our state variable becomes false. We make him jump up 10 pixels, so then he can get into that if statement. That if statement connected by our ands is then true. And he can move up the stage. And when we click on the down, or below our player's Y value, it runs this part of our code, move down equals true. We move him down 10 pixels. And then that kind of gate, this is kind of like a locked door right here. This locked door then becomes true because our player's Y value is in between our player 1 height divided by 2 and our stage height, so he's in between. This will be true now. As long as he stays in between these values, he's true. And if he's true, then we run this code and we either move him down or up. Now, if you're not used to looking at a lot of code, this might seem like like it's a little bit of a code, but the more you look at it, the more it'll make sense to you. This is actually a good way of kind of moving that player up. And then importantly, we learned our AND operator today. Remember that both sides have to be true. You put a Boolean statement on each side of the AND operator. And if both sides are true, it makes the whole Boolean statement true. And if either side is false, it makes the whole Boolean statement false. That's important that we learned our AND operator. And we looked at our OR operator. Now, if you don't want him moving all the way down the stage, what should we change this guy to? Yes, very good. So notice that right now he's checking to see if his Y value, which is in the middle of him, has reached stage.height. So it's seeing if the middle of him has reached stage height. So you could actually change where you want him to check to see to stop. So you could subtract your player 1.height divided by 2. That'll make him his Y value that he's checking a little bit higher and not the whole height. So hopefully, you know, many of you kind of thought how to do that already. That is excellent if you thought how to do that already. And that way, what we're checking to see if his Y value has reached player 1's height above stage 1 stage height. So we're checking, you know, a little bit above stage height. So that way he'll stop right there above it instead of going all the way halfway down. And of course, Control S and save it, and Control Enter always test your code after you change it. I think that works pretty good, and you can think that if you're playing it on the E-pad, this will work okay. You know, you click up and down, it'll work pretty okay, I think. Remember, our clicks turn to our taps on our E-pads. We do definitely want all of our games to work on our E-pads. That's our goal in here. Make everything work either on a computer or an E-pad or an iPad. We live in a mobile world with different devices, and we want our applications and our code to work on all those devices. Cool. So most people get that to work. Excellent. All right. We're at 9:30. We can implement the second part of this code pretty easy because I'm going to have you copy and paste some of it actually. So we're just going to get the ball to move, and then I think we'll make our enemy, our artificial intelligence for our enemy next time here. Now I'm not going to make you type this function. I used to make people type this function, then it was like heck trying to get to debug. So I just gave you guys the code, and I'm just going to let you copy and paste this one. And then we'll go through it, and we'll kind of look at what it's doing here, and you guys can comment it. Does that sound good? That way, I think it saves all of us a headache of having to write this code. So I gave you guys this code either in that text file that I attached in Blackboard or in the zipped folder. And there's an AS file in there. And this is called your public function ball movement function. And it is a whopper of a function. Okay? And to tell you the truth, I actually got it from another tutorial online too. But we can go through and look at them. It uses lots of math in there to calculate how to move our ball object. And I'm just kind of talking up here while you guys are downloading and unzipping that file. And once you get that file downloaded and unzipped, the part of the code you're going to copy, of course, is your public function ball movement. So there's the top of him. And then he goes all the way down. He's a big function, and then I did label this ending curly bracket so you'll know when to stop copying, pasting. And so you'll do a Control-C and copy that whole ball movement function. Just going to move our ball back and forth across the screen. Now remember that when you're pasting it, it's very important that you paste this code outside of any other function. You can just paste him on the end here. So you'll see your ball movement function here. Now there's a couple other things that we'll have to copy and paste from that file. We're going to have to copy and paste where we declare these variables. So in order to get this function to work, we had to have some variables. One of the variables we keep track of is how fast our ball is moving, so he just doesn't jam really fast. And, he slowly starts to move, so he looks more realistic. And that's our x speed. And then if we keep on increasing the ball, he'll start getting faster and faster where we can't even catch him or move our player fast enough to hit the ball. And so we have this variable called max speed. So when we set max speed to a certain max speed, the ball, when it reaches that max speed, you can think that if x speed reaches max speed, this if statement will be false when he goes beyond max speed, and so he won't be able to increase his speed anymore of the ball. Now note also that we check the x speed to see if he's greater than 0 or less than 0. And what this does is it makes it either move to the left, which is negative x, or to the right, which is positive x. Okay? So if he's moving in the positive x direction, if he's already positive, it'll keep moving in that positive x direction. And then if he's less than 0, that means the x speed is negative, meaning we're subtracting our x, it's moving in the left direction. We'll keep on moving him in the left direction by subtracting x. Okay, so that's what this code here is doing. In fact, we should write notes in here. Since I'm letting you copy and paste this, we should at least write the notes so that we understand what it's doing. Okay. So this part of the code is moving or changing the x speed. Changing our x speed to move the ball either left or right, and keeping it under max speed. So we don't want it moving too fast, so we're going to keep it under, how fast max speed is set to. In fact, you can think in your levels, if you changed max speed as you leveled up, you can make the ball move faster and faster and faster by increasing that max speed in your new levels. The only kind of variable you have to change to make the ball move faster is set max speed to a higher value, then the ball can move faster. All right, so that's what this part of the code's doing. Now this part of the code here is where we move the actual ball. So we change the ball's x and y values here. So this part of the code is actually moving the ball. Okay, so when we change his x and y values by adding x speed and by adding y speed, then we're moving the ball on the screen. Okay. Now I had some trace statements in here. Remember that you can put trace statements to see what's going on in here. But, now this is doing the same thing for our y that this was doing for our x up here. Well, a little bit differently. So he's not changing the speed so much as if he's changing the y direction. So if our y value of our ball is beyond stage height, meaning that he's reached the bottom of the screen, right? And our y speed is greater than 0, then we'll subtract his y value, which brings him up the screen. So it's going to bounce him off the bottom of the screen. Go other direction. Hitting the bottom, go the other direction. Actually, I left my comments in here for you. And then if the ball is hitting the top, and we can even put ball in here. If the ball is hitting the bottom, go the other direction. And if the ball is hitting the top, go in the other direction. Okay, actually, comment out this part of the code because we haven't programmed our player to do anything yet. In fact, in my game here, just so you know what that was doing, is see that little cat there? He was going to and playing that little cat function that he claws the ball. So that's what this function here was doing, or this function call, so we can comment that part out so we program our player to actually do something, right? If the ball hits the player's paddle, so this is checking to see if the ball has hit our player's paddle. Then we calculate the speed, x speed and y speed needed for a correct angle and set them to that value. I used to go more in depth in here, but I will let you guys read through this a little bit. If you're a math person, then this makes sense to you what it's doing, probably. Otherwise, I guess we can take it for granted that it works, right? I don't really feel like going too in depth with that. Now we haven't made our enemy yet. We haven't made the other player yet. So actually, either we need to make our other player. I called him enemy to get this part of our code to work. But let's go ahead and just comment out this part of our code, and then we'll test just the beginning parts of our code. So to make a block comment, you hit a slash and a star at the beginning of your comment. Notice everything turns gray because he's going to be in the comment. So at the beginning where I said added this part, put a slash and a star to start a comment. And then at the end, where it says end hit test, go ahead and put a star and then a slash to end our comment. Okay? So we just commented out this small part here. This is the beginning, this is the end. And notice that when we ended our comment, then we still have code at the end here. Alright, so we got that huge function pasted in there, hopefully. Hopefully well. Now there's one thing that we need to do first. We need to make our ball object. This is going to fail still unless we have this ball object here. So let's make our ball object. And then we'll test this code. Making the ball object's easy. We do that in the flaw file. Okay? And then we'll declare them and instantiate them in here. Alright. So let's go to our flaw file and make a ball for ourselves. Remember later on we can change our objects. I'm going to go ahead and just use my oval tool. If you hold down the shift key, it'll make a perfect oval, though it doesn't really matter all that much because we're going to change them out with our own character, our own ball anyway, unless you really want to use this ball. So I just drew a circle. Then I'm going to F8 him because in order to add him into our code, he's going to have to be a movie clip. I'm going to name him ball with a capital B, and then export for action script, import him to export for action script, of course. everybody got their ball. We can delete him from the stage because over in the library, he's over there. Should see him over here in your library. Now let's make him in our code. We'll take a break right after we get our ball working, and then we can help make sure everybody's code's working. Now to make our ball object, we just say, okay, here we're going to make a ball. Now notice this is a lowercase b, because this is his variable name. And I'm going to declare him type ball, and this uppercase b means this is a class name. So I'm going to do my declaration here with my instance variables because it makes sense to make our ball an instance variable. Remember, this is up at the top of our program with our other instance variables. And then we'll instantiate them down here where we instantiate all of our instance variables. Just we can put them right about here. So far, the order in which we've instantiated our instance variables doesn't really matter all that much. So we'll make a new ball. We'll set its x and y value to something. I want them to appear in the middle of my stage. That's a good, it'll be stage width divided by 2. We'll stick them into the middle of my stage. On the x-axis. And then to put them in the middle of the y-axis, we'll do our stage height divided by 2. And then importantly, we add him to the stage. Should appear on the stage now. So we declared him, we instantiated him, and I think that's all we need to do to make him work now. Because now we can use him down here. Oh, one very important thing we need to copy and paste though, like I said before, is we need to know what these variables are. So this is going to be a big load of variables that we're going to copy and paste, but we need all these variables. So I'm assuming everybody had that function, they copied this function, right? They all copied the ball movement function. So in that same file that you had open, at the top of that file are all of our variables, and they're a big lot of variables to do our ball movement. They're all right here. And notice that they're declared and instantiated right here at the top, which I let fly. You know, normally we would, you know, instantiate them in the constructor, but we'll just let it go here. That's fine. So it's kind of a lot of work to copy and paste them. Then we'll come up here and we'll paste them with our other instance variables. And I like to leave a space because these are all of our, so these are all of the ball movement, variables. These are all variables that we need to make that function work. Okay, so I went ahead and copied and pasted all those variables from that other file. Alternatively, you could type them all out, but that's not work. And then he should work. Oh, and then one last thing we have to change in that function is last time I called him player, not player 1. So there's 3 places where player is mentioned. And it'll tell you the line numbers of where you pasted him. So just change player to player 1. Unless you really named him player and not player 1, then that's okay. One more player. Now the reason he's not moving, I bet you can realize why he's not moving, maybe you can't. Why isn't our ball movement function running?
Didn't add a event lesson there?
Yeah, we didn't add them in the code anywhere. The only part of the code that's running is our constructor. And our constructor has an event listener for the enter frame event, but our enter frame event never called our function. So what we'll do is we'll copy that ball movement function and actually just call him here in the on enter frame event. Once he's called, notice that the code does actually work for hitting our object, but then he goes off and then never lands on the right because we don't have an enemy over there. That's the part of the code we commented out. So we need to make our enemy. But I think this is a good place to kind of break. We can make our enemy on Wednesday, or if you realize all you have to really do is make an enemy object, declare him, instantiate him, and then uncomment that code in your enemy object actually will work. More or less. He won't move, but he will actually get moved. But I think this is a good place to break. And things you can work on to the end of class here is you can work on finding a better character. To change out that character, all you have to do is go in your flaw file, double click player, and then replace him with your character, and he'll work. Just remember that when you get your character, to keep that crosshair in the middle of your character, because that's how we've programmed this thing. This reference point has to stay in the middle. And you can also change out your ball to something else. You saw in that one example someone used a head. You can use whatever you want. Okay. And you just double click on that movie clip, go in here, and you can change those objects. And then I think we'll take the rest of the class, make sure everybody's code works. You can save your files. And then also, if you have not uploaded your Flappy Bunny / Flappy Bird, Flappy whatever, remember you'll want to get that done. You can upload him. You want to upload your flaw to the assignment and class assignments. And upload your Swift to the discussion. And we've been pretty laid back in here, but you do need to turn in stuff to get a grade at the end of this class, okay? So make sure that you turn in your Swift file and your flaw file to that assignment, so that way that one's complete. If you haven't done so already. Okay, and it's only 6 people have, so we need to get them in. Okay. And this thing died on me.